Good morning, students. Chapter 8, Gravitation. Yes, it is the last topic of this chapter and it is named satellites. Yes, you know satellite. A body revolving around any planet is called satellite. There are two types of satellite actually, natural satellite and artificial. For example, moon is natural satellite of Earth, while another artificial satellites are also launched by different countries, okay, in different orbits around Earth. Okay, so that data you have to remember from textbook. Here about satellite, yes, satellites, they are revolving around planets. Okay, they are revolving around planets, like planets revolving around sun. Like planets revolving around sun. Okay, so yes, for planetary motion of planets around sun, we know Kepler's 3 laws. So similarly, we can apply this Kepler's law for motion of such satellites. Okay, moon, for example, moon. Okay, so moon is revolving around Earth. So moon is satellite, natural satellite of Earth, and its orbit is almost circular. Its orbit is almost circular. Okay, yes, it is natural satellite. There are some artificial satellites also. Okay, so here, what is question? The question is obtain equation of orbital velocity and time period of satellite. Orbital velocity and time period of satellite. So see, for that we are taking one situation. Okay, like this. Okay, if is Earth, its center, okay, one satellite is revolving in such orbit, satellite is revolving in such orbit with mass m. Okay, now radius of this orbit from center of Earth, let it is okay, obviously satellite is outside Earth, obviously satellite is outside Earth, so yes, it is Earth. Okay, from center of Earth, satellite is revolving in radius in orbit of radius with some velocity, as it is performing circular motion, nearly circular motion. So for that circular motion, it has some velocity, and I am assuming they let its velocity, suppose it is rotating in this direction, so velocity at each and every point it is in direction of tangent drawn at that point. So yes, here it is tangent, means here it is its velocity is VO, orbital velocity. So here it is figure. Now I will write data. Okay, as shown in figure, let satellite of mass m is revolving in almost circular orbit, as shown in figure, that satellite of mass m is revolving in almost circular orbit having radius r, around again, as shown in figure, that satellite of mass m is revolving in almost circular orbit having radius r around Earth. Okay, where we can write, as shown in figure, it is clear. It is the total distance, but we know that radius of Earth from this point. Okay, radius of Earth, it is I, and it is called h. That is height above the surface of Earth. Where r is equal to, you can write it is I plus h. Right? You can write it is I plus h. Okay. So now see, as shown in figure, it is clear. This satellite is revolving around Earth with some speed. Okay. So yes, speed or velocity of satellite, speed of satellite around Earth in circular orbit, is called orbital speed or orbital velocity is. Okay. Now it is clear, okay, it is performing circular motion. So yes, you know that from chapter number 5, laws of motion. What is required for circular motion? Yes, for circular motion, it requires centripetal force. Okay, so in this case, that centripetal force for this circular motion of satellite, that centripetal force is provided by, yes, gravitational force between Earth and satellite. Gravitational force between Earth and satellite. So here we have to write one statement. Here we have to write one statement. K for circular motion of satellite. For circular motion of satellite require centripetal force is provided by gravitational force between planet and satellite. Clear? So yes, this is a statement. Okay. Yes, that satellite is performing rotational motion. Okay, sorry, it is performing circular motion. And yes, we know that for circular motion, what is required? Yes, centripetal force is required, and that centripetal force is provided by gravitational force between planet and satellite. Okay, so now we can write one equation. Yes, we can write one equation. It is Earth. So what is mass of Earth? It is m. Yes. This satellite is performing circular motion. Its mass is m. Its speed is v0. Okay, so therefore centripetal force is equal to gravitational force Centripetal force, its equation is half m v0 square. Why half m v0 square? You understand? Okay, the satellite of mass m is moving its speed v0. Gravitational force between planet and satellite means between Earth and satellite. So what is mass of Earth? M. Mass of satellite m. Distance between them r. So I can write g m upon r square. Clear? So yes, this m cut. Okay, and therefore I can write v0 square is equal to sorry, it is a centripetal force. What is the equation of centripetal force? Centripetal force means it is m v square upon r. Yes, it is m v square upon r. Okay, so yes, r cut, m cut. So v0 square is equal to, it is only g m upon r. Again, what is the equation of centripetal force? mv square upon r. mv square upon r. So v0 square is equal to gme upon r, and therefore v0 is equal to under root gme upon r. Or you can also write this equation as or v0 is equal to under root gme upon r means it is re plus h. R means it is re plus h. So it is equation of orbital speed or orbital velocity. Simple. How to obtain equation of orbital velocity or orbital speed? It is easy. First of all, draw figure, description of figure, then yes, as this satellite is performing circular motion, for circular motion what is required? Centripetal force, that is mv square upon r. It is provided by gravitational force between satellite and earth. So you just have to compare, okay? Yes, compare equation, you will get equation of VO, that is orbital velocity. What is second question? Second question is this time period of satellite. Time period of satellite. Now how to obtain this equation of time period of satellite? See here. Yes, from this equation, that is V0 square is equal to Gme upon r. V0 orbital speed is equal to distance upon time. Yes, speed is equal to distance upon time, and we know that for one rotation, okay, V0 is equal to, we know that for one rotation, what is distance traveled? Circumference, and time, that is nothing but time period. So yes, V0 we can write 2 pi r upon p. Remember this one, okay? I can write V0 is equal to 2 pi r upon t. So here it is V0 square. So therefore it is 4 pi square r square upon t square is equal to G ne upon r. Get it out? Okay, now make this t square as subject. So therefore, if you make t square as subject, then t square we have to write in numerator. T square is equal to t square you have to write in numerator. Okay, so it is 4 pi square r cube upon gm Now yes, it's 4. Okay, now see, 4 constant, pi constant, G constant, me constant, yes, constant. So therefore here we can say 4 pi G me are constants, So I can write t square is proportional to r cube, and see, it is nothing but Kepler's law of period. It is Kepler's law of period. That is square of time period is directly proportional to cube of radius. Kepler's law. Okay, we have discussed for elliptical orbit. So for elliptical orbit you have to write semi-major axis. So for circular orbit you have to write radius. That is, t square is proportional to cube of radius of orbit. Clear? So yes, it is t square is proportional to r cube. Okay, so it is Kepler's law of period. Now see, here it is. It is t square is equal to 4 pi square r cube upon g ne. If I want to find t only, then how to write this equation? Then t is equal to, it is 4 pi square upon g ne raised to 1 by 2. Because if you have to remove square, you have to do square root, and here it is r raised to 3 by 2. R raised to 3 by, clear? So t is equal to 4 pi square upon g ne raised to 1 by 2, r raised to 3 by 2. Yes, you can also replace r by r plus h. So t is equal to, it is 4 pi square upon g ne raised to 1 by 2. Here we can write r plus h raised to 3 by 2. Okay, so yes, it is equation of time period. If you are given case satellite is very close to surface of earth, then it means nearly here. So h is equal to 0, or you can say r is equal to r. So I will write here that extra point. Okay, if satellite is close, very close to surface of Earth. Surface of Earth. Simply H is equal to 0, or you can say R is equal to I. Okay, so simple. In this equation you have to put R is equal to R, or in this equation you have to put H is equal to 0. Then another data known, so you can easily find what is time period. Clear? Okay. Any doubt? Hello? Okay. Okay. So yes, it is all about this question, which is obtain equation of orbital velocity and time period of satellite. Okay, you have to remember this equation of orbital speed, that is VO is equal to under root G me upon R. VO is equal to under root G me upon R, because in next theory to obtain equation of energy of satellite you have to use this equation. Clear about this? Okay? Yes. Now next theory. Now, next question for satellite is C. Obtain equation of energy of satellite revolving around Earth. Okay, obtain equation of energy of satellite revolving around Earth. Now energy means, yes, you know that total energy means kinetic energy plus potential energy. Kinetic energy, so total energy is equal to kinetic energy plus potential energy. Now we know that orbital speed of satellite is VO is equal to under root G me upon R. So therefore kinetic energy of satellite K is equal to half m v square. Okay, half m v square. So is equal to is half m. Yes, v square means square of this, which is G m upon R. So if you rearrange this equation, you can write it is G m upon 2. It is equation of kinetic energy. Okay. Now equation of potential energy of satellite. Potential energy of satellite. What is potential energy of satellite? U is equal to, see, satellite of mass m is revolving in orbit of radius r, means satellite is at distance r. So from center of Earth, if satellite is at distance r, then what is equation of potential energy? Minus Gm upon R. Remember theory of potential energy? Yes, U is equal to minus G m1 m2 upon R. Simple. Okay. So yes, U is equal to this minus G m upon R. So it is kinetic energy, it is potential energy. So therefore total energy of satellite E is equal to, it is K plus U, that is kinetic energy plus potential energy. So therefore E is equal to K, that is K, it is Gm upon 2R, Gm upon 2R, and potential energy is minus Gm upon R. Okay, so therefore E is equal to, if you take G and M upon R common, G and M upon R common, here you have 1 by 2 minus 1. Now 1 by 2 minus 1 means minus 1 by 2. 1 by 2 minus 1 is equal to, it is minus 1 by 2. Yes, it is minus 1 by 2. So here it is, how to write, is equal to, therefore E is equal to G M upon R. Here it is minus 1 by 2. So therefore E is equal to minus G M upon 2R. So what is total energy of satellite? E is equal to minus GMM upon 2R. See, minus sign indicates that satellite is in binding of Earth. Okay, negative sign indicates the satellite is in binding of Earth. It is not free. Clear? Okay, so yes, it is equation of energy. Now see, it is kinetic energy of satellite. It is equation of potential energy. And it is equation of total energy. If you observe these three equations, see, kinetic energy is equal to GMEM upon 2R. Total energy is minus GMEM upon 2R. Only sign change. Only sign change. And this equation is, it is nothing but 2 times. So, in short, how to remember? In short, how to remember? If kinetic energy is equal to x, or I can say plus x. Okay, if kinetic energy is plus x, then total energy is equal to minus x. And yes, kinetic energy GMEM upon 2R I have assumed as x. GMEM upon 2R x. Then see, GMEM upon 2R as x, so it is equal to minus x. Then what about u? So yes, u is equal to, it is minus 2x. U is equal to, it is minus 2x. So for calculation of some MCQs, you have to remember this one. Okay, a k is equal to plus x, k is equal to minus x, and u is equal to, it is minus 2x. Clear about this? Okay, so yes, it is second theory, that is obtain equation of energy of satellite revolving around sun. Yes, E is negative, total energy is negative. Total energy is negative means satellite is in binding with Earth. Clear? Okay, so if I ask you one question, did you remove Earth? No, okay. To remove satellite from binding of Earth, what is energy given to satellite? It is plus GMEM upon 2R. That is escape energy. Okay, clear about this? So yes, it is about satellites. Okay, what is energy of satellite revolving around Earth? Okay. Now, yes, this question over. Okay, this question over here. Now, types of satellite. Yes. Next question. Types of satellite. Types of satellite. Okay. First type of satellite is. It is different question. Okay. First type is geostationary satellite. Geostationary satellite. Now, why it is named geostationary satellite? See, time period of such satellite. Now, what is time period? Hello, you know time period. Okay, time to complete one revolution. So, time period of such satellite is 24 hours. 24 hours means it is equal to time period of Earth its own axis. Its own axis. Its own axis. Okay. So yes, time period of such satellite is 24 hours and it is equal to time period of Earth about its own axis. And therefore, whenever such type of satellites are viewed from Earth, you will find stationary. Yes, you will find them stationary. Okay, whenever we observe, whenever we view such satellite, they are stationary. We found that, yes, we find that they are stationary. Because it's simple. Time period of satellites is 24 hours. Time period of Earth about its own axis, it is also 24 hours. So as Earth is rotating, satellite is also rotating. As Earth is rotating, satellite is also rotating. As Earth is rotating, satellite is also rotating. Yes or no? Earth, satellite, Earth, satellite, Earth, satellite. They both are revolving with the same, in same time, the same speed. Okay. So yes, we can say as this time is same, is that time period is same. Whenever we view it from surface of Earth, we will find it is stationary. Okay, such planets are observed stationary whenever viewed from surface. That's why it is named geostationary satellite. Okay. One finds such satellite stationary. One finds such satellite stationary when viewed from Earth. Okay, now it is fixed. Okay, for geostationary satellite, time period of such satellite is 24 hours. Yes, time period of such satellite is 24 hours. So for such satellite, you have to take T is equal to 24 hours. Now we have obtained one equation of time period. Remember in previous theory. T is equal to, what is T is equal to? It is 4 pi square. Yes, it is 4 pi square upon GME whole raised to 1 by 2, R raised to 3 by 2. Yes, R raised to 3 by 2. You know equation. Okay. T is equal to, it is 4 pi square upon GME raised to 1 by 2, R raised to 3 by 2. R raised to 3 by 2. T 24 hours, 4 you know, pi you know, G you know, M you know, and if you calculate R, you will have value of R. It is 4260 kilometer. R, that is distance from center. What is height above the surface? That height above the surface, H is equal to, it is 35860 kilometer. So see, hello, listen. For such geostationary satellite, distance from center, that is R, and height, it is fixed. We cannot launch geostationary satellite to any other orbit, to any other distance, to any other height. No, we not. Okay. For geostationary satellite, time period is fixed, that is 24 hours, and for that, distance from center or height above the surface is fixed. That is this. Clear? Okay. Yes. Such type of geostationary satellites, they are used in many applications. Okay, for GPS, etc., etc., etc. So yes, it is given in your textbook that you have to read and you have to remember. Okay. Second type, yes, such geostationary satellite. This geostationary satellite, they revolve in equatorial plane. In equatorial plane. In equatorial plane means, okay, in such direction. Okay, clear? Like this. Like this. Okay, they are revolving like this. Any doubt? Any doubt? Okay. So yes, they are revolving geostationary satellite. If it is Earth, then geostationary satellites are revolving like this. Okay. Second, polar satellite. Polar satellite. Chalo, what is polar satellite? Polar satellite. So from polar, pole means north pole, south pole. So from it is clear, such polar satellites, okay, they revolve around Earth in such way. Means north to south. Clear about this? Means north to south. Okay. Such polar satellites, they are placed at height nearly 800 kilometer. Nearly at 800 kilometer. Okay. So its height above the surface is nearly 800 kilometer. Its time period, it is equal to nearly 100 minutes. 100 minutes means, see what happens in polar satellite. Polar satellites, they revolve in this direction, and during their motion, they cover only some particular path of Earth. For example, okay, Earth, for one rotation, for first rotation, suppose, okay, yes, it is Earth, it will rotate in such direction. Okay, now here I will do another thing. Okay, suppose it is rotating like this. Okay, so during its first rotation, it will cover only such portion of Earth. Then during second rotation, it will cover another portion. During another rotation, it will cover another portion. During next rotation, it will cover next portion. So yes, during its one revolution, it will cover only one part, only a part of Earth. Okay, so yes, Earth is rotating, polar satellites, they are also rotating. So during the entire motion of such polar satellites, they can scan Earth numbers of times. Clear? So yes, for this geostationary satellite and for this polar satellites, you have to remember such data only. Okay. Yes. What is geostationary satellite? In which plane they are revolving? In which plane these polar satellites they are revolving? Okay. So yes, that you have to remember. Data you have to remember. Okay. So yes, it's all about satellites. Yes, the more information is given, okay, which country have launched which satellite, that you can read from your textbook. Okay, it's all about theoretical part. Clear? So it's all about satellite. It's this is the